Hello, and welcome back to Sleepy Universe. Whatever day you've had, you can let it go now. There is nothing you need to do, nothing you need to solve. Tonight, we'll take a gentle journey through our immediate cosmic home, the solar system. We'll explore 100 quiet facts about its sun, its planets, and the silent, drifting spaces in between. You don't need to remember any of them. Your only task is to listen and let your mind drift on the gentle currents of our sun's influence. So, find a comfortable position. Feel your body grow heavy, supported by your bed. Let the weight of the day melt away. Just listen and imagine we are floating, unmoored, in the deep, quiet sea of space, looking back at our own blue, sleeping world. Now, let your awareness float up beyond the moon and into the peaceful darkness where our sibling worlds dance. Let's begin. The warmth you feel on your skin on a clear afternoon is not merely daylight. It is a physical touch, a message sent across 93 million miles of void, a whisper of energy that began its journey in the core of our star thousands of years ago. This star, our sun, is not just one object among many in our celestial neighborhood. It is the neighborhood. Its immense gravity, a silent, unseen hand, holds every last atom of our entire cosmic estate in its thrall. Every spinning planet, every tumbling asteroid, every fragile comet of ice, all are dancing to the slow, stately music of its pull. Consider that over 99.8% of all the substance in this vast system, from the fiery surface of the sun itself to the very air in your lungs, is contained within that single, brilliant sphere. We, on our tiny rocky world, and all the other worlds you will dream of tonight, are nothing more than the leftover dust, the fleeting whispers of matter from its formation, forever circling the gentle nuclear furnace that gave us life, and that will, one day, gently take it back. Let your mind drift to the innermost world, Mercury, a place where the very concepts of a day and a year become untethered from our earthly understanding. Here, time is stretched and woven into a strange, slow rhythm. A single day on Mercury, measured from one sunrise to the next, lasts longer than its entire journey around the sun. It spins on its axis with such a languid, sleepy slowness that it must complete 2 full, scorching orbits around our star just to experience a single cycle of day and night. Imagine the slow, cosmic breath this creates. One hemisphere bakes endlessly under a sun that appears 3 times larger than in our sky, its surface heating to temperatures that could melt tin for what would feel like an eternity. Meanwhile, the other side faces the pure, black emptiness of space, its heat slowly bleeding away into the ultimate cold for a night that lasts just as long. It is a world of profound extremes, not of violent storms, but of a silent, patient, and perpetual turning, a slow-motion world in the fast lane around the sun. Venus, that brilliant, unwavering diamond you see in the twilight sky, is a world of profound and serene deception. Its beautiful, unblemished glow comes from a thick, perpetual cloak of clouds that reflect the sunlight with a perfect, placid whiteness. But beneath that soft, luminous veil lies a reality that feels almost like a dream of hell, a vision of a world that took a tragic turn. The pressure on its surface is crushing, equivalent to the weight you would feel a kilometer deep in Earth's ocean, a heavy, silent blanket of carbon dioxide. The temperature is a constant 470 degrees Celsius, hot enough to melt lead, to warp metal, to instantly extinguish any earthly notion of life. This is the result of a runaway greenhouse effect, a process that spun out of control billions of years ago and now maintains the planet in a permanent, scorching equilibrium. It is a beautiful, brilliant warning, a serene and sweltering paradise lost, a permanent monument to the delicate, invisible balances that keep our own world cool and alive. Its beauty in our sky is a silent elegy for the world it could have been. Our Earth, from a distance, appears as a perfect blue marble, a sphere of stunning smoothness. But this is an illusion of scale. In truth, our world is not a perfect geometric shape. It is gently squashed, bulging softly at its equator, like a spinning ball of dough, yielding to an invisible force. This gentle oblateness, this subtle imperfection, is a gift from its motion, a permanent, graceful deformation caused by the centrifugal force of its relentless daily spin. The planet is, in a very real sense, fluid, its very shape a testament to the dynamic forces it lives within. The diameter from pole to pole is over 26 miles shorter than the diameter across the equator. It is a quiet, constant reminder that our world is not a static, dead rock, but a vibrant, dynamic body, breathing and flexing on a planetary scale, a subtle flaw in its perfection that is, in fact, what makes it uniquely and beautifully our living, spinning home. The moon is not merely a companion following us through space. It is a part of Earth itself, a profound and intimate piece of our own world's deepest history, written in rock and set forever in the sky. The most captivating story of its origin tells of a time of cosmic violence in the solar system's wild youth, when a nascent planet, perhaps the size of Mars, grazed the still molten Earth in a cataclysmic impact. This event did not just shake our world, it unmade it for a moment, scattering a colossal ring of vaporized rock and molten debris into orbit around the wounded Earth. Over time, drawn together by their own gravity, these particles coalesced, cooled, and solidified, becoming the serene, cratered companion we know today. When you gaze up at its familiar, tranquil face, you are not looking at a stranger. You are looking at a piece of your own planet, a fossil of Earth's most violent and creative day, now a silent, watchful guardian, a constant, peaceful reminder of our world's turbulent birth. The red glow of Mars is not the fiery light of a forge, but the soft, pervasive blush of ancient, patient rust. This entire world, from the soaring summit of Olympus Mons to the deep, shadowed floor of the Valle Marineris, is coated in a fine, endless dust of iron oxide, the very same substance that forms on an old, forgotten nail left in the rain. This is a planet slowly exhaling its history, its surface gently oxidizing in the thin, dry, and sun-bathed air that whispers perpetually across its deserts. It is not a symbol of anger, but a quiet, slumbering world, the color of dried clay and autumn leaves. a testament to the slow, silent work of chemistry over billions of years of profound stillness. The rust is a gentle ghost, a silent record of a time when water may have flowed freely, a forgotten chapter of the planet's history written in a delicate reddish patina across its entire global surface. The asteroid belt, so often imagined as a dense and chaotic junkyard of colliding rocks, is in truth one of the most serene and empty places in our solar system. It is a vast, sprawling plain of space, a cosmic desert where the distances between the scattered, rocky inhabitants are so immense that they become lonely, solitary islands adrift in a black ocean. If you were to stand on the surface of one of these asteroids, you would gaze out into a star-flecked void, with no other asteroid likely visible to your naked eye as anything more than a moving star. They are not a crashing, violent battlefield, but a sparse and silent archipelago of primordial worlds, each fragment a unique entity, following its own predetermined, lonely path around the sun, forever separated by millions of miles of perfect, undisturbed, and peaceful vacuum. Jupiter is far more than a banded and swirling planet. It is a miniature solar system in its own right, a silent, protective patriarch whose immense presence defines the architecture of our cosmic neighborhood. Its gravity, the strongest of any planet, acts as a benevolent cosmic shepherd, its long, invisible reach sweeping up and capturing countless comets and asteroids that would otherwise spiral inward on chaotic, dangerous paths. For billions of years, its stable, slumbering bulk in the outer system has served as a gravitational shield, helping to clear the chaotic debris of the early solar system and granting the inner, rocky worlds like our Earth a far more peaceful and stable environment in which to form oceans and nurture life. It is a gentle giant dreaming in the outer dark, whose immense gravitational dreams quietly orchestrate the safety and stability of our entire celestial home. The great red spot of Jupiter is a storm that has been churning for centuries, a vast, swirling tempest that has raged for at least 400 years, and likely much longer. A timeless maelstrom in an atmosphere of hydrogen and helium. This colossal, anticyclonic whirlpool is so immense that our entire planet Earth could be swallowed within its crimson and salmon-colored currents with room to spare. Yet, from our distant, peaceful vantage point, it is not a vision of terrifying violence, but a serene, slow-moving feature, a peaceful, watchful eye in the complex and banded atmosphere of the gas giant. It is a storm that has outlasted every empire, every human life, every single structure we have ever built, a perpetual, silent vortex spinning with a timeless, majestic patience that dwarfs all of human history into a single, fleeting moment. Saturn's rings are not a solid, permanent bracelet of light. They are a fleeting, beautiful, and dynamically changing dance of countless billions of ice particles, each no larger than a snowball, each following its own perfect, independent orbit around the planet's calm equator. They are a cosmic carousel of frozen rubble and dust, shimmering with a collective brilliance that belies their fragile individual nature. And they are profoundly transient, a temporary glory in the life of the solar system. They are likely the remnants of a shattered moon or a captured comet that wandered too close, a glorious but ephemeral crown that will, over the next few 100 million years, either be gently pulled into the planet by gravity or scattered silently into the dark of space. We are living in a brief, privileged cosmic moment, gifted with the sight of this delicate, intricate ballet of ice before it slowly, gracefully fades away into utter silence. Saturn's moon, Enceladus, is a small, brilliant, and active world, a celestial body that sighs continuously into the surrounding void. From fractures in its icy south pole, immense geysers of water vapor and tiny, sparkling ice crystals erupt from a hidden, global ocean deep beneath its frozen crust, jetting hundreds of miles into the airless space. These magnificent plumes form a faint, ethereal ring of ice around Saturn, a gentle, ongoing donation of its inner essence to its parent planet. This is not a dead, static world, but one that breathes and exhales, its internal heat and confirmed liquid water whispering the most tantalizing possibilities of a hidden, aquatic reality, thriving in the absolute darkness beneath its bright, cracked, and icy shell. Uranus is a world that has been knocked onto its side, a planet that rolls around the sun in a profoundly different orientation, like a slow-motion, lopsided top spinning through the void. Its rotational axis is tilted so dramatically that it essentially orbits the sun, with one pole pointing directly at the star for half of its long 84 Earth-year journey, and the other pole for the remaining half. This gives the planet the most extreme seasons in the solar system, with each pole experiencing 42 years of continuous, unending sunlight, followed by 42 years of utter, profound darkness and cold. It is a serene, blue-green marble, a quiet testament to some ancient, colossal impact that knocked it into this eternal, graceful, and deeply tilted slumber. Neptune, the outermost ice giant, is a world of profound and powerful internal energy, radiating more than twice the heat from its deep, turbulent interior than it receives from the distant, shrunken sun. This great inner warmth drives the fastest winds in the entire solar system, with supersonic gales screaming through its atmosphere of methane and hydrogen at speeds exceeding 1,200 miles per hour. These are not the chaotic, random storms of a raging world, but the smooth, powerful, and seemingly permanent jet streams of a deeply dynamic and fluid planet, a silent, deep blue symphony of relentless motion, playing out in the cold, dark, and sun-starved reaches of our solar system's outer frontier. Beyond the orbit of Neptune, in the frigid, sunless realm of the Kuiper Belt, exists a vast and silent population of icy worlds, of which Pluto is the most renowned ambassador. These are not simple, barren rocks, but complex geological worlds with slowly shifting glaciers of nitrogen ice, mountains of water ice as hard as steel, and tenuous, transient atmospheres that freeze and fall as exotic snows onto their surfaces. They are the quiet, frozen archivists of the solar system's earliest days, pristine time capsules, preserving in their deep cosmic freeze the original, unspoiled materials and conditions from which the planets first coalesced, holding secrets from a time long before the Earth was even born. The Oort cloud is a theoretical, vast, and almost unimaginably distant spherical shell of icy planetesimals that represents the true final frontier of our solar system, the absolute limit of our sun's gravitational influence. It is an immense gravitational moat, a cloud of 1 trillion frozen comets so far away that the sun is merely a particularly bright star in their perpetual black sky, offering no warmth and only a hint of light. This distant, silent reservoir is the source of the long-period comets that occasionally, gracefully, visit our inner solar system. Silent wanderers from the ultimate outskirts of our sun's domain, reminding us that our star's gentle pull stretches nearly a quarter of the way to the next nearest star in the galactic void. The solar system moves in a silent, gravitational harmony, a great, slow music of the spheres that is felt rather than heard. The orbital periods of the planets are not random. They are often locked in delicate, mathematical resonances with one another, a celestial clockwork of immense precision. For every 2 orbits that Jupiter makes around the Sun, for instance, Saturn completes almost exactly 1, a gravitational dance that keeps their interactions stable and predictable. These subtle, invisible harmonies help to maintain the solar system's grand architecture over billion-year timescales, a silent, mathematical music of ratios and rhythms that keeps the great clockwork of our cosmic neighborhood ticking in peaceful, graceful, and eternal order. The sun has a heartbeat, a slow, rhythmic pulse that governs the ebb and flow of its magnetic personality. Over a cycle of approximately 11 years, our star gently pulses, its surface becoming a tapestry of dark sunspots and brilliant flares before settling back into a period of calm. This slow, cosmic breath, driven by the churning of plasma deep within its interior, influences the very nature of space weather throughout the entire solar system, shaping the heliosphere and affecting planetary atmospheres. It is a gentle, rhythmic exhalation of energy and magnetism, the fundamental living pulse of our celestial home, a reminder that our star is not a constant, static light, but a dynamic, breathing entity. The countless craters that pockmark the face of the Moon, Mercury, and Mars are not random features. They are the ghostly, fading scars from a violent, primeval epoch known as the Late Heavy Bombardment. During this tumultuous time, vast swarms of asteroids and comets, the leftover building blocks of planet formation, rain down upon the inner solar system in a cosmic storm, churning the surfaces of young worlds and reshaping their landscapes. These craters are silent memorials to that chaotic era, the faded bruises and gentle dimples left by a long-past tempest of cosmic debris, a permanent record of the violent processes that shape the serene worlds we see today. Mars may appear as a dry, dusty, and lifeless world today, but its life-giving water did not entirely vanish into space. Vast, secret reserves of it are locked away in the deep cold, trapped within its bright polar ice caps and in extensive, sprawling glaciers of pure water ice buried just beneath the ubiquitous, reddish dust. This is not the water of flowing rivers or deep oceans, but a frozen, silent reservoir, a sleeping memory of a wetter, more Earth-like past hidden beneath the surface. It waits in a deep cosmic freeze, a preserved relic of a different climate, for a change that may never come, a testament to the world that Mars once was. Jupiter's moon, Io, is a world of perpetual, violent rebirth, the most volcanically active body in the entire solar system. Its sulfurous interior is constantly kneaded, stretched, and superheated by the immense gravitational tug-of-war between the colossal mass of Jupiter and the resonant pulls of its sibling moons, Europa and Ganymede. This relentless tidal heating powers hundreds of active volcanoes that spew fountains of molten rock and paint the moon's surface in a surreal, chaotic palette of yellows, oranges, reds, and blacks. It is a world in a constant state of eruption and renewal, a stark, fiery contrast to the silent, dead, and frozen moons elsewhere, a restless, burning jewel caught in the unyielding gravitational grip of its giant parent planet. Saturn's moon Titan is a world cloaked in a perpetual golden haze, an organic smog that hides its surface from prying eyes, creating a realm of profound and mysterious beauty. Here, the fundamental processes that shape a planet are both familiar and utterly alien, for Titan possesses the only other active, complex hydrologic cycle we have found in our solar system. But the fluid that drives this cycle is not water. It is liquid methane and ethane, which exist here as we find water on Earth. Methane clouds gather in its orange skies, releasing a gentle, slow-motion rain that darkens the hillsides. This rain gathers into streams and rivers that carve sinuous, hauntingly familiar channels through the icy landscape, eventually flowing into vast, calm seas and lakes that cluster near its polar regions. It is a profound and silent landscape, a cold, dark mirror of our own active planet, where the very liquids that shape the world are the building blocks of natural gas, flowing and evaporating under a sky that forever hides the sun and stars, a breathtaking testament to the diverse and surprising possibilities of planetary evolution, a world that holds the recipe for life as we don't know it. Deep within the Earth, a powerful and ancient engine is constantly at work, a dynamo of spinning molten iron and nickel that generates our planet's vast and protective magnetic field. This invisible shield, the magnetosphere, extends tens of thousands of miles into space, forming a teardrop-shaped bubble that surrounds our world. It acts as a divine deflector, bending and channeling the continuous, lethal stream of charged particles from the solar wind, a constant, supersonic barrage that would otherwise slowly but surely erode our atmosphere and bathe the surface in harmful radiation, rendering the planet a barren wasteland. You cannot see it, you cannot feel it, but this deep, churning metallic heart is the silent, invisible guardian of the very air you breathe and the climate you live in, a dynamic, living force field generated by the restless, fiery core of our world, a fundamental and non-negotiable condition for the existence of our fragile biosphere. Within the brilliant, seemingly static ring systems of the gas giants, a delicate and essential ballet is perpetually performed by tiny, often overlooked dancers. These are the shepherd moons, small, frequently irregular bodies whose tiny but precise gravitational influence is crucial to sculpting and maintaining the sharp, defined edges of the planet's magnificent rings. They orbit within or nestled against the rings, their gravity gently herding the countless billions of ring particles, clearing gaps like celestial gardeners and keeping the lanes distinct and beautiful, preventing the rings from slowly spreading out and dissipating into a featureless, homogeneous disk over millions of years. They are the silent, celestial choreographers, their small, precise, and endless dances ensuring the grand, icy ballet of the rings continues its beautiful, orderly, and breathtaking performance, a testament to how even the smallest forces can shape the most magnificent of cosmic structures. The solar system is not a static, completed museum piece, a perfect clockwork that was wound up at the dawn of time and left to run. It is a dynamic and continuously evolving system, a symphony that is still being composed, still settling into its final, stable form billions of years after its birth. Planets migrate minutely in their orbits over eons, their paths subtly shifting from gravitational interactions. Moons are tidally evolving, their orbits slowly expanding or contracting, drawing them incrementally closer to or further from their parents. And asteroids are gradually grinding themselves down through countless gentle collisions over billion-year timescales. We are living inside a slow-motion engine of perpetual change, a celestial mechanism that is still fine-tuning itself, a living, breathing entity that continues to write its own story, reminding us that the cosmos is not a snapshot, but a moving picture of unimaginable length and depth. The thin, vibrant blue line of Earth's atmosphere, which appears from the surface as an infinite, protective dome stretching to the heavens, is in reality an incredibly fragile and fleeting membrane, a mere whisper of gas against the utter, absolute blackness of space. From the vulnerable vantage point of orbit, it is revealed in its true nature, a vanishingly thin, glowing skin, a delicate, shimmering bubble clinging tenaciously to the curvature of the planet. This precious, infinitesimally small layer, which sustains every known living thing, is all that stands between the vibrant, noisy biology of our world and the absolute, airless, radiation-scoured, and silent void. Its delicate, breathtaking nature is a silent, humbling, and constant reminder of the rare and precious equilibrium, the miraculous balance of physics and chemistry that makes our world a solitary, life-filled sanctuary in the immense, cold, and indifferent cosmic dark. In about 5 billion years, the Sun will exhaust the hydrogen fuel in its core, marking the beginning of its gentle, inevitable, and majestic transformation from a stable, life-giving star into a swollen, dying red giant. It will swell to 100 times its current size, its outer layers expanding in a final, slow exhalation to engulf the orbits of Mercury and Venus, and likely searing the Earth itself into a barren, molten cinder, vaporizing the very rocks and oceans that once teemed with life. The inner solar system, the familiar neighborhood of our childhood, will be utterly remade in this final, slow, and catastrophic act of stellar evolution, a beautiful and terrible sunset for our entire celestial neighborhood. This is the predetermined, peaceful end of our familiar solar system, a distant, future transformation written into the laws of physics, a destiny that lends a profound and quiet poignancy to the stable, life-giving era we are so fortunate to inhabit now, a golden age in the long life of our star. The Voyager 1 and 2 spacecraft, launched in a more optimistic era in 1977, are now humanity's farthest flung artifacts, our silent robotic ambassadors drifting in the incomprehensible emptiness of the interstellar medium beyond the protective bubble of the sun's influence and into the galactic realm. They carry with them the golden records, gold-plated phonograph discs containing a curated sample of the sounds, images, music, and greetings from Earth, a message in a bottle cast into the unimaginably vast cosmic ocean. They are our silent, enduring emissaries, sailing on into the galactic night long after their nuclear hearts have grown cold and their instruments have fallen silent, carrying a whisper of our world, our culture, our dreams, and our existence into the endless, waiting silence between the stars, a testament to a species that once looked up and dared to send a part of itself to the stars. The very material that constitutes our solar system, the iron in your blood that carries oxygen, the calcium in your bones that gives you structure, the silicon in the rocks beneath your feet, is not new. It is recycled stardust, the ancient ashes of generations of massive, short-lived stars that lived and died in spectacular supernova long before our sun was even a glimmer in a nebula. These colossal creative explosions seeded the surrounding galactic clouds with these heavy forged elements, which then coalesced under the gentle, persistent pull of gravity to form our star and its entire planetary family. We are not just living in the universe is living within us. We are a part of this grand cosmic recycling program, a continuous, majestic cycle of stellar birth, death, and rebirth that has been running for over 13 billion years, and we are its most recent conscious product. Despite its reclassification as a dwarf planet, Pluto maintains a profound and graceful gravitational relationship with its cosmic neighbor, the ice giant Neptune. For every 3 orbits that Neptune completes around the Sun, taking 495 Earth years, Pluto makes exactly 2, a perfect and stable 3-to-2 orbital resonance. This beautiful mathematical harmony, this celestial minuet, ensures that the 2 bodies never closely approach, even though their paths, if drawn on a flat map, appear to cross. They are locked in a gravitational dance that prevents chaos and ensures their mutual stability. A stunning showcase of the beautiful, precise mathematical order that underlies the movements of even the most distant, small, and solitary worlds in the far reaches of our solar system. Earth's moon is not a silent, static orb. It is a world that subtly contracts and groans as its interior slowly cools over billions of years, losing the internal heat of its formation. This gradual global shrinking creates lobate scarps and thrust faults on its surface, leading to moonquakes that can last for much longer than their earthly counterparts, sometimes resonating for over an hour in the absolute silence. These tremors are the gentle, deep sighs of a world slowly settling in upon itself, a quiet, seismic song echoing across its barren plains and vacant seas, a reminder that even our seemingly dormant, ancient companion, has an inner, dynamic, and geological life, a slow, cold heartbeat that we are only just beginning to perceive. Deep within the crushing, lightless atmospheres of Uranus and Neptune, scientists believe that one of the most extraordinary weather phenomena in the solar system occurs. The immense pressure and temperature, thousands of kilometers below the cloud tops, can compress carbon atoms found in atmospheric methane into crystalline structures, forging a literal rain of diamonds. These diamonds are thought to form and then slowly fall like glittering solid hail through the slushy, exotic interior layers of these planets, perhaps eventually accumulating into a thick layer around the core. It is a hypothetical, yet wondrous and poetic phenomenon. A silent, beautiful, and perpetual storm of gems falling forever in the lightless, crushing depths of these distant, serene, and blue worlds. Within the hot, swirling protoplanetary disk from which our solar system formed, there existed a fundamental and decisive thermal boundary known as the snow line or frost line. Inside this line, close to the intense heat of the young sun, water could only exist as vapor, leaving behind the refractory, rocky, and metallic dust that would eventually coalesce into the dense, inner terrestrial planets: Mercury, Venus, Earth, and Mars. Outside this line, in the cooler depths of the disk, water could condense directly into solid ice, vastly increasing the amount of available building material and allowing the rapid, runaway accretion of the massive, icy cores that would later attract vast envelopes of gas to become the Jupiter, Saturn, Uranus, and Neptune we know today. The entire architecture of our solar system, the very division between the rocky and the gaseous worlds, was dictated by this simple thermal frontier. Mars, lacking a large, stabilizing moon like our own, experiences dramatic and chaotic shifts in the tilt of its rotational axis over million-year timescales. This phenomenon, known as true polar wander, means that the Martian north and south poles, the fixed points of its rotation, have not always been in their current locations. The entire planet's crust, unmoored by the gravitational anchor of a large satellite, can slowly and ponderously slide over its mantle, reorienting itself like a loose skin on a sphere and completely altering the planet's climate history, making the locations of ancient ice and evidence of past water a moving, evolving, and deeply complex puzzle for planetary scientists to unravel. Saturn's moon Iapetus is a world of stunning, almost impossible contrast. One hemisphere as bright as freshly fallen snow and the other as dark as black velvet or freshly laid asphalt. This striking global duality is likely due to a complex and slow process where dark, reddish dust, possibly swept up from smaller outer moons, is preferentially deposited on Iapetus's leading face as it orbits Saturn. Meanwhile, its trailing side remains clean, bright ice. As the dark areas absorb more sunlight and warm up, they trigger a thermal feedback loop, causing the underlying water ice to sublimate and deposit itself on the colder, brighter areas, further concentrating the dark material and creating one of the most visually dramatic, bizarre, and enigmatic objects in the entire solar system. The precise isotopic composition, found within the most primitive meteorites, the oldest unaltered rocks in the solar system, contains the faint but definitive chemical signature of a nearby supernova explosion. This cataclysmic stellar event, which occurred just as our solar system was beginning to coalesce from a quiet cloud of gas and dust, may have provided the critical shockwave that triggered the gravitational collapse of our primordial nebula, while also seeding it with newly forged heavy elements essential for forming rocky planets and life. We are, in a very real and chemical sense, the children of that ancient, fortuitous, and violent stellar death. Our very existence is an echo of a giant star's final moment. On the clearest, darkest nights, free from the pollution of artificial light, a faint, ethereal, pyramid-shaped glow, known as the zodiacal light, can be seen reaching up from the horizon in the direction of the sun. After evening twilight ends, or before morning twilight begins. This is not the light of a distant galaxy or nebula, but the collective reflection of sunlight from countless trillions of microscopic dust particles that populate the plane of the inner solar system, a vast lenticular cloud of fine debris stretching throughout the realm of the terrestrial planets. It is the faint, shining dust of disintegrated comets and the collisional debris of asteroids, a permanent, gentle, and cosmic haze, illuminating our local cosmic neighborhood from within, the dusty floor of our celestial home, catching the sun's rays. The asteroids of our solar system are not only found in the main belt between Mars and Jupiter. Two vast, stable swarms of asteroids, known collectively as the Trojans, are trapped in the gravitational Lagrange points along Jupiter's orbit, leading and trailing the giant planet by a steady 60 degrees in its path around the Sun. These are the unseen captives of gravity, sharing Jupiter's orbital highway without ever catching up to it or falling behind, a silent, rocky retinue, thousands in number, that accompany the king of planets on its eternal, stately journey, never colliding with it, held in a perfect, timeless gravitational balance. The sun's surface is not a uniform, placid ball of calm gas, but a seething, dynamic ocean of plasma, its structure dominated by a complex and ever-shifting magnetic field that bursts through from the interior. This intense magnetic activity manifests as relatively cool, dark sunspots, as brilliant, explosive solar flares that release the energy of millions of hydrogen bombs, and as immense, graceful loops of plasma called prominences that can arc hundreds of thousands of miles into the coronal void before collapsing or raining back down. The sun's face is a constantly changing canvas of magnetic storms and activity, a visible testament to the powerful, turbulent, and dynamic forces churning relentlessly within its deep, radiative, and convective interior. The heliopause is the final, theoretical boundary of our solar system, the distant, turbulent zone where the sun's outgoing solar wind, a stream of charged particles, finally yields to the pressure of the interstellar medium, the thin gas, dust, and cosmic rays that fill the space between the stars. It is the ultimate outer shoreline of our solar system, the place where the sun's cosmic influence, its breath, effectively ends and the galactic environment begins. Crossing this invisible, turbulent frontier, as the Voyager probes have heroically done, means truly leaving our solar home behind and entering the vast, unexplored, and genuine ocean of the galaxy, a transition from the familiar to the truly unknown. The entire solar system, in all its majestic complexity and beautiful motion, is held together and set in its stately dance by a single, universal, and fundamental force: gravity. This same gentle, invisible attraction that causes an apple to fall from a tree, that gives you weight in your bed, and that holds the moon in its endless orbit around the Earth, also governs the billion-year dance of the gas giants, the intricate, resonant orbits of tiny moons, and the slow, graceful million-year fall of a comet from the Oort cloud into the warmth of the inner system. The entire majestic, complex, and beautiful structure of our cosmic home is an emergent property of this one, simple and silent law of the universe, a grand, silent symphony of motion, played on the invisible strings of space-time itself, connecting your presence here, now, to the motion of every world in the sky. Our sun does not sit motionless at the center of a static system. It is itself engaged in a slow, graceful waltz through the galaxy, carrying all of its planets, moons, and comets along with it. This journey is not a simple circle, but a subtle, bobbing motion as it moves relative to the local standard of rest, the galactic gravitational average. As it travels, it moves through regions of space with slightly different densities of interstellar gas and dust, causing the protective bubble of the heliosphere to breathe in and out, subtly changing the boundary between our solar home and the galactic environment. We are all, every atom of the solar system, passengers on this grand stellar voyage around the galactic center, a journey of 225 million years per orbit, a slow-motion pilgrimage through the cosmos. Beyond the orbit of Neptune, stretching out into the profound cold and darkness, lies the Kuiper Belt, a vast torus of frozen worlds and planetary building blocks that were never incorporated into a larger planet. This region is the deep freezer of the solar system, preserving pristine ices and organic compounds from the dawn of our system's formation. The objects here, like Pluto, Haumea, and Makemake, are not mere rocks. They are complex worlds with geology, seasons, and atmospheres that freeze and fall as snow. The Kuiper Belt is a silent, expansive archive, holding the unspoiled recipe of the early solar system in a deep cosmic freeze, a reminder of our humble beginnings. Planetary atmospheres are not permanent, immutable features. They are dynamic, breathing entities that can be slowly stripped away into the void. This process, atmospheric escape, happens in several ways. For smaller worlds like Mars, solar wind can blast it away over billions of years. For giant planets, their immense gravity can sometimes launch fast-moving atoms into space. And for worlds like Io, volcanic outgassing constantly replenishes a temporary, tenuous shroud. The presence and thickness of an atmosphere is a delicate balance between a planet's gravity, its magnetic field, and the relentless influence of the sun, a balance that determines whether a world is a lush paradise, a barren desert, or a crushing inferno. The The small moons of the solar system, particularly those of Mars and the outer planets, are often not the neat spheres of their larger cousins. They are captured asteroids or collision fragments, and their low gravity is insufficient to pull them into a spherical shape. Instead, they are lumpy, potato-shaped, and deeply irregular, looking more like cosmic potatoes or jagged rocks than classic moons. Their bizarre forms, like Martian Phobos and Deimos, or Saturn's sponge-like Hyperion, are a direct result of their weak gravity, unable to overcome the structural strength of the rock and ice they are made from, presenting a wonderfully misshapen face to the cosmos. A beautiful and profound gravitational harmony exists between three of Jupiter's largest moons, Io, Europa, and Ganymede. For every single orbit that Ganymede completes, Europa makes exactly 2, and Io makes exactly 4. This 1 to 2 to 4 orbital resonance is not a coincidence. It is a stable, locked configuration that keeps their orbits predictable and prevents them from drifting into chaos. This constant, rhythmic gravitational tugging is also what heats Io's interior, driving its spectacular volcanism, and likely keeps Europa's subsurface ocean liquid. It is a celestial dance of immense precision, a gravitational melody that orchestrates the geology of worlds. Deep within Jupiter, where the colorful cloud decks give way to layers of metallic hydrogen and perhaps a rocky core, the pressure reaches levels almost impossible to comprehend. It is a place where hydrogen, the lightest element, is compressed into a liquid metal, able to conduct electricity and generate the planet's immense magnetic field. The pressure at the core may be tens of millions of times greater than the atmospheric pressure on Earth's surface, a crushing weight that fundamentally alters the nature of matter itself, creating a state that we cannot replicate for more than a fraction of a second in our most powerful laboratories. The asteroids in the main belt are not a random assortment. They are organized into families, groups of asteroids that share similar orbits and compositions. These families are the descendants of a single larger parent body that was shattered in a catastrophic collision billions of years ago. By studying these families, astronomers can piece together the history of violent impacts in the early solar system, understanding the forces that shaped the planets and delivered water and organic materials to the young Earth. The asteroid belt is not just rubble. It is a cosmic graveyard with a genealogy, telling the story of the system's violent youth. The most overwhelming feature of our solar system is its profound, staggering emptiness. The planets are mere specks, isolated islands in a vast, dark ocean. If you were to shrink the sun to the size of a grapefruit in New York, Earth would be a pinhead over 50 feet away, and Jupiter would be a marble a few blocks distant. The nearest star, another grapefruit, would be over 2,000 miles away in Los Angeles. This scale is a humbling reminder that space is not just up there. It is an immense, dominant void, and our worlds are the rare, precious exceptions. Earth's magnetosphere is not a symmetrical bubble. It is stretched by the solar wind into a long, comet-like tail that extends far beyond the moon's orbit, in the direction away from the sun. This magnetotail is a region of tangled magnetic fields and trapped plasma, a quiet, turbulent wake left by our planet as it plows through the solar wind. It is a dynamic structure, constantly storing and releasing energy, and it plays a key role in the beautiful, energetic phenomena of the auroras, funneling solar particles toward the poles where they ignite the atmosphere in a silent, shimmering fire. On airless worlds like Mercury and the Moon, there are craters at the poles whose floors are in permanent, eternal shadow. These are some of the coldest places in the entire solar system, with temperatures hovering just a few dozen degrees above absolute zero. In this profound, timeless cold, water ice and other volatile compounds brought by cometary impacts can remain stable for billions of years. These shadowed craters are nature's perfect deep freezes, icy time capsules that may preserve a record of the ancient water delivery system that filled the inner solar system. The solar system did not form in a calm, orderly manner. The protoplanetary disk was a violent, turbulent place, a cosmic demolition derby where planetesimals collided, merged, and shattered. Giant impacts were the rule, not the exception. A Mars-sized body striking the young Earth to form the Moon, a colossal impactor potentially stripping Mercury of its outer layers, and another possibly knocking Uranus onto its side. This era of chaos and violence was, paradoxically, the creative forge that hammered out the diverse and stable family of planets we see today. Earth is surrounded by a vast, incredibly tenuous cloud of hydrogen atoms that extends tens of thousands of kilometers into space, far beyond the exosphere. This is the geocorona, a faint UV glowing halo that is the outermost part of our atmosphere. It is the final fading whisper of our planet's gaseous envelope, a testament to the gentle but persistent escape of our lightest element into the interplanetary void. This ethereal shroud is the true, ultimate boundary of our world, a ghostly footprint in space. Every element in the solar system heavier than iron was forged not in the steady heart of a living star, but in the most violent events in the universe. Supernova explosions and the mergers of neutron stars, the gold in a wedding ring, the uranium in a power plant, the iodine in your body, all were created in these cataclysmic blasts and scattered across the galaxy, eventually to be incorporated into the nebula that gave birth to our sun and planets. We are literally made from the ashes of stellar catastrophes, the recycled debris of cosmic violence. The Earth's magnetic north and south poles are not fixed in place. They wander continuously, and every few 100,000 years, they flip entirely. This geomagnetic reversal is a complex process generated by the turbulent dynamics of the planet's molten iron core. During a reversal, the magnetic field weakens and becomes multipolar, leaving the planet's surface more exposed to cosmic radiation. This invisible deep Earth process is a reminder that even our fundamental planetary shields are dynamic and ever-changing. The plumes of Enceladus are not simple geysers. They are a direct sample of a global, subsurface saltwater ocean, venting into space from tiger-stripe fractures in the Moon's south polar region. These jets contain water vapor, ice particles, and a surprising cocktail of organic molecules, including simple hydrocarbons. By flying through these plumes, The Cassini spacecraft tasted this alien ocean without ever landing, revealing a world with all the key ingredients for life as we know it: water, energy, and chemistry. It is a world that whispers of potential biology in its silent, icy breaths. Mercury's surface is one of the most ancient in the solar system, a heavily cratered landscape that has remained largely unchanged for over 3 billion years. With no atmosphere to cause erosion and minimal geological activity, for most of its history, its surface is a pristine record of the late heavy bombardment. Studying Mercury is like looking back in time to the solar system's most violent era, a window into a period when giant impacts were the dominant force shaping the terrestrial planets. Titan's thick, nitrogen-rich atmosphere is a vast chemical laboratory where solar, UV radiation and energetic particles break apart methane and nitrogen molecules, allowing them to reform into incredibly complex organic compounds. These include tholins, reddish, tar-like polymers that give Titan its orange hue and likely rain down to the surface. This ongoing planet-wide prebiotic chemistry makes Titan a natural experiment in the steps that may lead to life, a world that is actively building the complex molecules that were the precursors to biology on the early Earth. The Sun does not rotate as a solid body. It is a ball of plasma that spins differentially. At its equator, it completes a rotation in about 25 Earth days, while near its poles, the rotation takes about 35 days. This differential rotation winds and stretches the Sun's magnetic field lines like taffy, building up immense magnetic energy that is eventually released in the form of sunspots, solar flares, and coronal mass ejections. This simple fact of its fluid nature is the ultimate driver of all solar activity and space weather. The intricate structure of planetary rings, the gaps, waves, and braids, is not random. It is the direct result of gravitational sculpting by embedded or nearby moons. A moon's gravity can clear a sharp gap in the rings, create spiral density waves that propagate for thousands of kilometers, or shepherd narrow ringlets into defined lanes. The rings are a magnificent, visible display of orbital mechanics and resonance, a cosmic art piece painted with the invisible brush of gravity. The finite speed of light, 300,000 kilometers per second, means we never see the solar system as it is, but only as it was. We see the Sun as it was 8 minutes ago, Jupiter as it was over 40 minutes ago, and Pluto as it was over 4 hours in the past. This creates a unique, layered perspective of our cosmic neighborhood, where more distant objects are seen further back in time. Even within our own celestial backyard, we are time travelers, looking into the past with every glance at the sky. When a planet passes directly between the Earth and the Sun, it does not create an eclipse of darkness, but casts a silent, perfect shadow that races across the star's fiery face, a phenomenon known as a transit. From our distant vantage, it appears as a tiny, perfectly black dot, a stunning demonstration of celestial geometry and scale. Mercury and Venus are the only planets that can perform this delicate ballet for Earthbound observers. their passages measured in hours of slow, graceful movement. This event is not merely a spectacle, it is the very method we use to discover worlds orbiting distant stars, watching for the faint, periodic dimming as an alien planet casts its own tiny shadow into the void, a technique that connects our local cosmic phenomena to the discovery of galaxies of new worlds. Comets are not simply dirty snowballs. They are the ancient, frozen archivists of the solar system's birth, time capsules that have preserved the pristine ices and dust from the very cloud that coalesced into our sun and planets. As a comet journeys into the inner solar system, the sun's warmth begins to gently exhale this frozen history, sublimating the ice and releasing gas and dust to form a vast glowing coma and magnificent streaming tails. These tails, one of dust and one of ionized gas, always point away from the sun, pushed by the solar wind and radiation pressure, becoming celestial windsocks. Each comet's visit is a temporary, beautiful unraveling of its core, a breath of primordial material that has remained unchanged for over 4 billion years, offering us a direct sample of our own cosmic origins. Despite its small size and proximity to the Sun, which suggests it should have cooled and solidified eons ago, Mercury possesses a massive, partially molten core of iron, a surprising and dynamic heart for such a seemingly dormant world. This liquid core generates a global, albeit weak, magnetic field, a miniature version of Earth's protective magnetosphere. The existence of this molten core challenges our understanding of planetary cooling and suggests a complex history, perhaps with insulating elements or a different formation process that left it with a hotter interior than predicted. Mercury, the innermost planet, thus holds a warm, liquid, and metallic secret at its center, defying simple expectations. The very outer boundary of our solar system, the heliopause, is not a quiet wall, but a turbulent, dynamic region where the sun's influence finally surrenders to the galactic environment. Here, the outward pressure of the solar wind collides with the inward pressure of the interstellar medium, creating a shockwave and a vast, teardrop-shaped bubble. This is the ultimate frontier of our star's domain, a cosmic graveyard where the energy and particles of the solar wind are dissipated and merged with the stuff of the galaxy. To cross this boundary, as the Voyager probes have, is to truly leave home and enter the interstellar wilderness. Beyond our solar system, we have discovered planetary systems that put our own to shame in their perfect mathematical harmony. In some of these systems, planets are locked in long, resonant chains where their orbital periods form precise, integer ratios with one another, like a complex multi-planet musical chord played on a scale of years. For example, one planet might orbit its star 3 times for every 2 orbits of its neighbor, and that neighbor might orbit 4 times for every 3 of the next. This delicate gravitational choreography reveals a system that formed quietly and has remained stable for billions of years, a silent symphony of motion that dwarfs the simpler harmonies of our own solar system in its complexity and precision. On the clearest, darkest nights, a faint, pyramid-shaped glow reaches up from the horizon after sunset or before sunrise. This is the zodiacal light, the collective reflection of sunlight from countless trillions of dust particles that populate the plane of the solar system. This ethereal glow is not a distant nebula, but the illuminated dust within our own cosmic neighborhood, the ground-up remains of asteroids and the dissipated tails of comets. It is a permanent, gentle haze, the dusty floor of our celestial home catching the sun's rays, a reminder that even the empty space between planets is filled with the fine, ground-down dust of cosmic history. The dark, smooth patches on the moon's face, known as maria or seas, are not bodies of water, but vast plains of ancient, solidified lava. These immense flows were unleashed billions of years ago when massive asteroid impacts cracked through the lunar crust, allowing the molten mantle beneath to well up and flood the giant basins. The lava that formed these plains was remarkably fluid, spreading out into expansive, level sheets that we see today as the man in the moon's features. These dark plains are a testament to a more violent, thermally active youth, a time when the moon's interior was still hot enough for widespread volcanism, painting its face with dark basaltic brushstrokes. The banded appearance of a gas giant like Jupiter is not a superficial pattern, but the visible manifestation of a complex, layered atmosphere in constant, turbulent motion. These bands are actually powerful, counter-flowing jet streams, racing eastward or westward at hundreds of miles per hour. The lighter bands, called zones, are regions of rising atmosphere, while the darker belts are where air is sinking. This organized global circulation pattern is a planetary scale weather system, driven by the planet's ferocious internal heat and its rapid rotation, creating a structured chaos of storms and winds that has persisted for eons. The dwarf planet Ceres, the largest object in the asteroid belt, is not a barren rock, but a world rich in water ice. Beneath its dusty, cratered crust lies a layer of briny water, a vast subsurface reservoir that may contain more fresh water than all of Earth. Bright, salty deposits in its famous Okator crater are the residue of recent, in geological terms, eruptions of this briny mud, suggesting that Ceres is a geologically active world, not a dead one. It is a cosmic ice mine, a water-rich protoplanet that never grew into a larger world, holding a significant fraction of the inner solar system's water in frozen, silent storage. While Mars has an atmosphere, only 1% as dense as Earth's, its winds are still a powerful, sculpting force over geological time. Unimpeded by oceans or dense air, these winds can reach hurricane speeds, lifting vast clouds of fine, abrasive dust that can engulf the entire planet in global dust storms. Over millions of years, this constant sandblasting action has eroded crater rims, carved wind streaks, and shaped vast dune fields. The surface of Mars is not static. It is being continuously, patiently, and silently resculpted by the thin, relentless breath of its own atmosphere, a slow-motion work of Aeolian art. The surface of Jupiter's moon Europa is a global jigsaw puzzle of ice, a cracked and fragmented crust floating on a subsurface ocean. The lines and fractures that crisscross its surface are not random. They are the result of tidal stresses from Jupiter's immense gravity, which flex and heat the Moon's interior, keeping its ocean liquid. These fractures are often stained with reddish-brown material, likely salts and complex organic compounds welling up from the ocean below. Europa's face is a map of its dynamic interior, a visibly stressed and broken shell, hiding a dark, salty, and potentially living sea. The internal heat of a planet is a relic of its violent birth, the leftover energy from the colossal collisions that built it. For giant planets like Jupiter, this primordial heat is so vast that the planet still radiates more energy into space than it receives from the Sun. This internal furnace, slowly contracting under its own gravity, drives the turbulent convection in its atmosphere, fueling its monstrous storms and powerful jet streams. This heat is the dying ember of the solar system's formation, a billion-year-old fire that continues to shape the weather on worlds far from the Sun. The solar wind does not travel forever. It eventually slows from supersonic speeds to a subsonic crawl at a boundary called the termination shock. Beyond this, in a region known as the Helios Heath, the wind is turbulent and compressed, like the wake of a ship, as it pushes against the interstellar medium. Finally, at the heliopause, the wind stops entirely, its particles merging with the galactic background. This gradual, silent dissipation of the Sun's breath marks the true fluid boundary of our solar system, a frontier defined not by a wall, but by a fading of influence. While not within our solar system, pulsars serve as the universe's most precise navigational beacons. These rapidly spinning neutron stars emit beams of radiation that sweep across space like a lighthouse, with a stability that rivals atomic clocks. By monitoring the precise timing of these pulses from spacecraft, we can triangulate their position in the solar system with incredible accuracy, a technique used by missions like Voyager to pinpoint their location in the deep, dark sea of interstellar space. They are our celestial GPS, using the dead, spinning hearts of ancient stars to guide our robotic explorers. High in the scorching, toxic atmosphere of Venus, a bizarre form of precipitation may occur. On the mountaintops, there is evidence of a highly reflective substance that scientists speculate could be a form of metallic snow composed of lead and bismuth sulfides. These heavy metals, vaporized by the intense surface heat, would rise, condense at higher, cooler altitudes, and then fall as a shimmering metallic frost onto the highland rocks. It is a surreal weather phenomenon, a snow that would not melt, but sublime back into a metallic vapor in the hellish heat below, a cycle of condensation and evaporation utterly alien to our experience. Neptune's moon Triton, a captured Kuiper Belt object, is one of the most geologically active icy worlds. Its surface, a brittle shell of nitrogen and water ice, is constantly being resurfaced by cryovolcanism, ice volcanoes that erupt liquid water, ammonia, or nitrogen gas. This activity, likely driven by tidal heating from Neptune, creates a young, complex surface with few craters, dotted with odd, cantaloupe-textured terrains and towering geysers of nitrogen that darken the icy plains. Triton is a world that groans and cracks under the strain of its capture, a frigid, active moon at the edge of the solar system. The Trojan asteroids are a vast collection of rocks trapped in gravitational sweet spots known as Lagrange points, leading and trailing Jupiter in its orbit by 60 degrees. In these stable zones, the combined gravitational pull of the Sun and Jupiter creates a pocket of equilibrium, where asteroids can orbit for billions of years without being ejected or colliding with the planet. These are not random rocks, but a captured population, likely as old as the solar system itself, silently sharing Jupiter's path, a permanent rocky retinue for the king of planets. Saturn's moon Iapetus is a world of stunning contrast, one hemisphere as bright as snow and the other as dark as charcoal. This striking duality is a self-reinforcing process. Dark, dusty material from outer moons coats the leading hemisphere, which absorbs sunlight and heats up. This heat causes underlying water ice to sublimate, which then migrates and refreezes on the colder, brighter trailing side and poles, further darkening the leading face. Iapetus is a cosmic yin-yang, a perfect demonstration of a thermal feedback loop on a planetary scale, forever locked in a state of extreme two-toned beauty. Billions of years ago, our Sun was only about 70% as luminous as it is today, slowly brightening as it ages. According to our models, this faint young Sun should not have provided enough heat to keep the early Earth from being a frozen ball of ice. And yet, geological evidence shows that liquid water and even life existed. This paradox suggests that the early Earth's atmosphere must have been rich in potent greenhouse gases like methane, creating a powerful insulating blanket that kept the planet warm despite a dimmer sun. Our planet's ability to regulate its climate and sustain life began in its most ancient chapters. The planets do not orbit a static center. They themselves cause the Sun to wobble slightly as they tug on it with their gravity. Jupiter, the most massive planet, creates the most significant effect, pulling the Sun into a small orbit around the solar system's shared center of mass, which lies just outside the Sun's surface. This wobble is a direct physical manifestation of the planet's gravity, a dance where the partner leads as much as it is led. It is the same principle we use to detect planets around other stars, watching for the subtle rhythmic tug they exert on their parent suns. The Sun does not burn in silence. It pulses with a deep, resonant heartbeat, its surface rhythmically rising and falling in a complex symphony of sound waves that traverse its fiery interior. This field of study, helioseismology, allows us to listen to the star's hidden chambers by observing the subtle, Doppler-shifted dance of its glowing surface. These oscillations are driven by the turbulent convection of superheated plasma, a continuous subsonic roar that is the Sun's internal vibrational voice. By decoding these silent vibrations, we can map its internal structure, rotation, and dynamics, listening to the deep, resonant music of a star we can never truly hear, a fundamental hum that underpins the very stability of our solar system and the light that warms our world. At Saturn's North Pole, a feature of breathtaking and seemingly artificial precision endures. A persistent six-sided jet stream known as the hexagon. This enormous rotating cloud pattern, large enough to engulf 4 Earths, is a natural atmospheric wave, a stable standing pattern that has persisted for decades, and likely since before humans first recorded history. Its sharp, unwavering edges and slow, stately rotation are a mesmerizing meteorological puzzle, a stunning demonstration of how fluids and gases can behave under the unique conditions of a rapidly spinning gas giant, creating a permanent hexagonal masterpiece of fluid dynamics on a planetary scale, a cosmic seal stamped upon the atmosphere of a ringed world. Venus presents a profound paradox in its motion. It rotates on its axis backwards or retrograde compared to the direction of its orbit around the Sun. This means that on Venus, the Sun would rise in the west and set in the east, a complete reversal of our earthly experience. A single day there, from one sunrise to the next, is longer than its year. This peculiar rotation is likely the result of a colossal impact early in its history that essentially flipped the planet upside down, or the cumulative gravitational tug of its thick, massive atmosphere over billions of years. It is a world that literally turned its back on the common direction of the solar system, dancing to a slow, inverted rhythm all its own. Comets carry within their frozen nuclei the ancient, unspoiled scent of the solar system's birth. When the European Space Agency's Rosetta probe analyzed the atmosphere around comet 67P/Churyumov-Gerasimenko, it detected a complex and pungent aroma, including the smells of rotten eggs, hydrogen sulfide, horse stable, ammonia, formaldehyde, and bitter almonds, hydrogen cyanide. This is the primordial perfume of our cosmic beginnings, the fragrant signature of the interstellar cloud that collapsed to form our sun and planets. Each comet that visits our inner solar system is thus releasing not just ice and dust, but the very smell of creation itself, a stark reminder that our origins were anything but sterile. The fine dust found throughout the solar system, in asteroid belts and comet trails, is not merely debris. Its composition often mirrors the dust found in the atmospheres of dying stars and in the disks around other young stars. We are connected to the galaxy not just by light and gravity, but by a common granular substance. The microscopic silicate and carbon grains that form the dark rifts in the Milky Way and the rings of Saturn are of the same fundamental family. The solar system is not an isolated entity, but a local collection of a universal, dusty material, a shared ingredient in the recipe for stars and planets across the cosmos. The Earth's rotation is gradually, imperceptibly slowing down, and the Moon is the cause. Through the mechanism of tides, the Earth's rotation transfers angular momentum to the Moon, pushing it about 3.8 centimeters further away from us each year. As the Moon recedes, our own day lengthens. A century from now, a day will be about 1.7 milliseconds longer. This is a slow, cosmic transfer of motion, a gentle braking force applied over billions of years, a dance of gravity and friction that has shaped the Earth-Moon system since its violent birth and will continue until, in the far future, Earth's day and month are equal in length. Our entire solar system is encased in a protective magnetic bubble, the heliosphere, forged by the Sun's extended magnetic field and the solar wind. This structure is not a perfect sphere, but a bullet-shaped shield, forged as the Sun moves through the galaxy. It deflects a significant portion of the galactic cosmic rays, high-energy particles originating from distant supernovae that would otherwise constantly bombard the planets. We are all, from Mercury to the Oort cloud, living inside this temporary pocket of relative calm, a stellar haven created by our Sun, a buffer against the raw, high-energy environment of the interstellar medium. Volcanism is not solely a phenomenon of rock and fire. On icy worlds like Saturn's Enceladus and Neptune's Triton, a different kind of volcanism occurs: cryovolcanism. Instead of molten rock, these cold volcanoes erupt volatile materials like water, ammonia, or nitrogen, which are liquid or gaseous under the surface, but freeze instantly in the vacuum of space. These eruptions create towering plumes and resurface the landscape with fresh, bright ice, revealing worlds that are not frozen dead, but geologically active, their interiors warmed by tidal forces or radioactive decay, suggesting hidden oceans and a potential for chemistry that transcends our earthbound definitions of habitability. In the far, far future, long after the Sun has shed its outer layers and faded to a white dwarf, it will begin its final transformation into a celestial diamond. Over trillions of years, the carbon and oxygen in its core will cool and crystallize, forming a solid, Earth-sized crystal of immense density. This crystal white dwarf will be the ultimate fate of our Sun, a cold, dark, and fantastically dense jewel orbiting the galactic center, a silent, glittering tombstone for the solar system, bearing witness to the universe's slow, inevitable descent into darkness and cold. The solar system is not silent. It sings a song of gravity and motion, a melody played on the strings of space-time, though our human ears are not tuned to hear its frequency. Every massive object, the Sun, Jupiter, even the Earth, as it moves, creates ripples in the fabric of space-time itself. The slow, stately dance of the planets generates a constant, ultra-low frequency hum, a gravitational vibration that passes through our bodies and through the Earth completely unnoticed. The galaxy is alive with the music of the universe, a silent song written in the language of relativity, and our solar system contributes its own quiet part to the chorus. Cosmic rays, high-energy particles, mostly from outside our solar system, are constantly striking the Earth's atmosphere and the surfaces of airless worlds. When they collide with atoms in rocks and soil, they can create new, rare isotopes. By measuring the concentration of these isotopes, like certain forms of helium and neon, scientists can determine how long a rock has been exposed on the surface, a technique called cosmogenic nuclide dating. These invisible, high-energy particles thus act as cosmic clocks, allowing us to read the exposure history of lunar soil, meteorites, and terrestrial landforms, turning the relentless rain from the galaxy into a tool for unraveling time itself. The solar system is subject to the gentle, pervasive pull of the Milky Way's gravity, a galactic tide. This tide is too weak to disrupt planetary orbits, but over millions of years, it is thought to influence the distant cloud of comets in the Oort cloud, gently nudging some of them from their stable orbits and sending them on a long fall into the inner solar system. The comet that becomes visible in our sky may have begun its journey because of the subtle gravitational pull of the entire galaxy upon our tiny outer frontier, a reminder that we are never truly isolated from the greater cosmic currents. The current configuration of the planets is a living memory of the solar system's formation. The location of the asteroid belt, the orbital resonances of the moons, the tilt of Uranus, the composition of comets, all are clues to a violent and dynamic past. By studying the present state of the system, we are doing celestial archaeology, piecing together the biography of our cosmic neighborhood from the scattered evidence that remains after 4.6 billion years. The solar system is its own history book, and we are only just learning how to read its chapters. The familiar constellations that have guided navigators and inspired storytellers for millennia are not permanent. The stars that form them are moving on their own independent paths through the galaxy. Over hundreds of thousands of years, these motions will slowly distort and eventually dissolve the patterns we know. The Big Dipper will open up, Orion will loosen his belt, and entirely new constellations will form for the eyes of future humans, or whatever looks up from Earth. The sky is a slow-motion kaleidoscope, and our familiar star pictures are but a single, fleeting frame in a film that lasts for eons. We often think of the solar system as a collection of separate worlds, but it is more accurately a single, interconnected entity, a complex system of gravitational and energetic relationships. A storm on the Sun can trigger auroras on Earth and disrupt the magnetic fields of the gas giants. The gravity of Jupiter shapes the asteroid belt and protects the inner planets. The water in Earth's oceans may have been delivered by comets from the Oort cloud. Every part is connected to the whole in a delicate, dynamic balance. The solar system is one body, and we are a conscious part of one of its cells. When we look at the planets, we are not seeing them as they are, but as they were when the light left them. We see Jupiter as it was roughly 40 minutes ago, Saturn as it was over an hour ago, and Pluto as it was 4.5 hours in the past. This creates a layered, asynchronous perception of our own neighborhood. If we could perceive it all at once, we would see each world in a slightly different now. Our view of the solar system is thus a collage of different moments in time, a tapestry woven from threads of time as much as from light. The force that holds the solar system together, gravity, is the same gentle force that holds you in your bed tonight, a universal tether connecting the vast cosmos to your quiet, resting form. The same invisible attraction that keeps the Earth orbiting the Sun and the Sun orbiting the galactic center is acting upon you right now. It is the force that gives you weight, that holds you gently but firmly to the surface of your world. There is no difference between the gravity that governs the dance of planets and the gravity that makes your body feel heavy and relaxed against the mattress. You are, in this very real sense, physically connected to the entire solar system. The detailed, close-up study of the solar system is a privilege of a brief moment in cosmic time. For almost all of human history, the planets were mere points of light. In just the last half-century, we have sent robotic emissaries to touch them, orbit them, and taste their atmospheres. And in the billions of years to come, the solar system will continue to evolve, with moons shifting, rings dissipating, and planets migrating. We are living in a unique golden age of discovery, a fleeting window where a conscious species on the third planet can reach out with its mind and its machines to comprehend its immediate cosmic home. For humanity, the solar system is our cradle, the nest from which we are just beginning to peer. It has provided us with a stable, life-giving star, a protective giant planet, a resource-rich asteroid belt, and a moon that stabilizes our climate and may have spurred our intellectual development through the mystery of its phases. Every world, from the scorching plains of Mercury to the frozen cliffs of Pluto, is a part of our extended home, a classroom for physics, a museum of geology, and a testing ground for our technology and our spirit of exploration. It is the garden in which we grew up. This is the final and most intimate fact. You are not just an observer of the solar system. You are a part of it. The calcium in your bones was forged in a long-dead star. The water in your body is older than the sun itself, a relic of the interstellar cloud that gave us birth. The rhythm of your heartbeat is a tiny biological echo of the planetary rhythms that govern our year, our days, our tides. You are the solar system become conscious, a collection of ancient stardust and primordial water assembled into a form that can lie in a bed on a small, beautiful world and contemplate the vast, beautiful, and silent home that created you. And so, we have reached the end of our 100 facts, 100 glimpses into the nature of our celestial home, 100 quiet thoughts to drift away with. You have journeyed from the fiery heart of the sun to the frozen frontier of the Oort cloud. Your mind has floated above the acid clouds of Venus, sailed through the rings of Saturn, and stood on the rusty plains of Mars. You have felt the immense, slow turning of the planets and the silent, invisible pull of gravity that binds it all together. And now, it is time to let it all go. To release these facts, these wonders, these names. They have done their job, gently occupying your thoughts, easing the transition from wakefulness to sleep. Feel the quiet weight of your body on the mattress, the softness of the sheets, the gentle rhythm of your own breath, in and out. The solar system is vast, but in this moment, your world is small and safe and warm. The planets will continue their silent orbits. The sun will continue its steady fusion. The solar wind will continue to blow. And you can rest. You are stardust. You are solar system. And as you sleep tonight, this magnificent spinning family of worlds continues its beautiful, silent dance with you as a cherished, conscious part of it. Let your breathing slow even more. Let your thoughts dissolve into dreams. The planets are watching over you. They are always there, constant, gentle presences in your sky. Sleep now. Dream of floating along the rings of Saturn. Dream of silent, icy geysers. Dream of a sunrise on a world with a backward sky. The solar system is whispering its lullaby, just for you. Good night.